These nets will fold to make 3D shapes. Match each net to the name of its shape. One has been done for you. So here we have a tetrahedron, because a tetrahedron is what we call a triangle-based pyramid. So we can imagine this triangle in the middle will be the base, and then these sides will all fold up, and so the corners will join together at the top to form a triangle-based pyramid or tetrahedron. Now here we have a cuboid. We can see the faces will fold up, and then this face at the bottom here will fold over the top. And the reason it's a cuboid and not a cube is that for a cube, the faces all have to be squares, and we have some rectangular faces as well. Now this shape here will fold to make a square-based pyramid, because we've got the square that's the base, and then the sides will fold up, so the points will join in the middle. And here we have a cube. It's like a cuboid, but all of the faces are square. 5 children grow pumpkins. This bar chart shows how heavy their pumpkins are. How much heavier is Joe's pumpkin than Holly's? So we have the children's names along the bottom. So if we find Holly's bar, we can read across and see that that weighs 2 kilograms. And then if we look for Joe's bar, go up to the top, and reading across, we can see that it's halfway between 4 and 5, so that's 4.5 kilograms. So we want to know how much heavier, which means we're finding the difference. So we need to subtract and work out 4.5 minus 2. That's 2.5, so Joe's pumpkin is 2.5 kilograms heavier than Holly's. We could also write our answer 2.5 kilograms, because a half is 0.5 as a decimal, or we could write that as 2,500 grams, because 2.5 kilograms is 2,500 grams, because remember 1 kilogram is 1,000 grams. Now, what is the mass of Dev's pumpkin to the nearest kilogram? So we can find Dev's bar, go up to the top and draw a line across. We can see that it's closer to 5 than it is to 4, and if we want the mass to the nearest kilogram, we need a whole number of kilograms. So to the nearest kilogram, Dev's pumpkin is 5 kilograms. It's probably about 4.7, but 4.7 to the nearest whole number rounds up to 5. These diagrams are all made of squares. Put a tick if exactly 1/3 is shaded, put a cross if it is not. So what we can do is find the fraction of each shape that's shaded, and then we can see if that fraction simplifies to 1/3. So here we have 4 parts shaded, and we have 12 parts altogether. Because we have 4 shaded parts and 8 parts not shaded, so that's 12 parts. And if we simplify 4/12, we can divide both the numerator and the denominator by 4. 4 divided by 4 is 1, 12 divided by 4 is 3. So because 4/12 simplifies to 1/3, we can say that 1/3 of this diagram is shaded. So now let's look at this diagram here. We have 2 parts shaded and 5 parts altogether. But 2/5 does not simplify to 1/3, so for this diagram we cannot say that 1/3 is shaded. Now here we have 3 parts shaded and 7 parts altogether. But again, just like with 2/5, we can't simplify 3/7, so we know that it's not equivalent to 1/3. Now for this last diagram, we need to be careful. Remember, for fractions, we need our parts to be of equal size. So what we could do is imagine we have 2 whole squares shaded, because 4 halves can make 2 wholes, or what we could do is divide these squares into halves as well. So that gives us 4/12 if we're dividing these squares in half, because it means we have 12 parts altogether and we have 4 parts that are shaded. And as we saw up here, 4/12 can be simplified to 1/3, so 1/3 of this diagram is shaded as well. Now if you decided to, rather than split the squares that were not split in half into half, instead you'd imagined 2 whole squares, you would have had 2 out of 6 or 2/6, and that could be simplified to 1/3 as well by dividing by 2. A, B, C and D are the vertices of a rectangle. Remember, the vertices are the corners or the pointy bits. A and B are shown on the grid. D is the point 3, 4. Write the coordinates of point C. Well, first of all, let's show D on the grid. It's the point 3, 4, and remember, the first number is down here, and then the second number in the coordinate is along the side. So we have 3, and then we need to go up 4, so point D is this point here. Now we're told that they're the vertices of a rectangle. So to make a rectangle, the coordinates for point C will need to be here. So that if we go down, that's 5, and across, that's 2. So C has the coordinates 5, 2. And if you weren't sure where to put the point to make a rectangle, remember, one thing you can do is turn your page, and then it's much easier to see how we can make a rectangle. Here is a sorting diagram for numbers. Write a number less than 100 in each space. So in this space here, we need a cube number that's even. Remember, a cube number is what you get when you multiply a number by itself and then multiply it by itself again. So 1 is a cube number because 1 times 1 times 1 is 1. But 1 isn't an even number because remember, even numbers end in 0, 2, 4, 6 or 8. Even numbers are multiples of 2. So let's find a different cube number. If we work out 2 times 2 times 2, that's 8, and 8 is an even number, so we can write 8 in this box here. We could have also worked out that 4 times 4 times 4 is 64, and that's an even number as well. So there are different possible answers for this question. Now for this box here, we need a cube number that's not even. So we could write 1 here because 1 isn't an even number, but it is a cube number because 1 times 1 times 1 is 1. Or we could work out that 3 times 3 times 3 is 27 because 3 times 3 is 9, and then 9 times 3 is 27, and 27 is not even, so we can write 1 or 27 in this space here. Now for this space, we need an even number that is not a cube number. Now there are lots of possible answers for this. We could write 2 because that's even, but you can't make the number 2 by multiplying a number by itself 3 times. Or we could have 4, 6, 10. There are lots of possible answers. And there are also lots of possible answers for this box here. We need a number that is not even, so we need an odd number that is not a cube number. So we can have 3, 5, 7, again, lots of possibilities here. But we can't have 1 because remember 1 is a cube number, because 1 times 1 times 1 is 1. Here are 4 triangles on a square grid. Write the letters of the 2 isosceles triangles. So for this question, we need to remember that isosceles triangles have 2 sides of the same length and 2 angles that are the same size. So B is isosceles because we've got 2 lines of the same length, and then these 2 angles at the bottom will be the same. So B is one of our triangles, and then our other isosceles triangle is triangle C, because again we've got 2 sides that are the same length and 2 angles that are the same. So this angle here and this angle here are the same size. So C is our other isosceles triangle. Remember, with triangles, if we've got 3 sides that are the same, then the triangle is not isosceles. We call a triangle with 3 sides the same an equilateral triangle. Or if all 3 sides are different, like what is the total mass of these apples? So we can see on the scale that it's halfway between 1 and 2, so that's 1.5 kilograms, because we can see down here we're weighing the apples in kilograms. Now 1.5 kilograms can be written as 1.5 kilograms, because 1/2 is 0.5 as a decimal. But the question doesn't say write your answer as a decimal, so we'd also get the mark if we wrote 1.5, because if the question doesn't say, you can write your answer as a fraction or as a decimal. The perimeter of this rectangle is 20 centimeters. So remember, the perimeter of a shape is the distance around the outside. The length is 6 centimeters. How long is the width of the rectangle? So we know that with rectangles, opposite sides are always the same length. So if this length is 6, then this length will be 6 as well. So to find the perimeter, we need to add 6 plus whatever the 2 widths are. And we're told that the perimeter is 20. So 6 plus 6 is 12. So 12 plus whatever the 2 widths are has to equal 20. That means the 2 widths together must equal 8, because 12 plus 8 is 20. And if the 2 widths together equal 8, then one width must equal 4 centimeters, because half of 8 is 4, or 4 plus 4 is 8. So the widths of our rectangle must be 4 centimeters, because that way, to get the perimeter, we have 6 plus 4 plus 6 plus 4, and that comes to 20. So the width is 4 centimeters.